Hi students, Mr. Myers here. Sorry for the glitch at the front end there. In this video clip, we're going to talk about ternary ionic compounds. Ternary ionic compounds are made of 3 or more elements, meaning that they contain a polyatomic ion. We've got some things here. We're going to talk about naming them as well as writing the formulas. So the gist of it is to name a ternary ionic compound. We're going to name the first element or ion. So if it's an element, a metal, for instance, like in our binary ionic compounds, then it's the same way. Where this changes then is that the anion, which is the second part, gets the name of the polyatomic ion. We don't have to do anything special. We just use the name of the polyatomic ion that is on your polyatomic ion list that you guys have been studying for this past week. So let's take this information and apply it. In this first slide from here, we're going to name the compound from the formula. Okay, so I'm going to get the pen up together. There we go. So we have Na3PO4. We're going to name the first element using the name of that element. So Na is sodium. And then, so that's there, that's a check mark. And then the PO4 here, think about for a moment what polyatomic ion is PO4 with a -3 charge. Okay, if you said phosphate, you are correct. So we have sodium phosphate is the name of this compound. All right, in the second one, we have Al2SO3 3. I will explain the parentheses when we get to the next slide, so be on the lookout for that. But here we have Al. This is aluminum, so we get the name of the first element. And then the second ion here, SO3, that one is sulfite. So we go aluminum, sulfite. Okay, and I'm using the TEC tablet or touchscreen computer in the classroom here, so it's not writing up very well, so I apologize for that. So the first one we had sodium phosphate up over here. The second one is aluminum, and then we have sulfite. So we just take the name of the polyatomic ion and write it out. This third one, the first element, our metal, is zinc. And then we look at the polyatomic ion. This is ClO3, which, as you know, is chlorate. So the name of this compound, ZnClO3 2, is zinc chlorate. All right, let's switch it up a bit and go from the formula, go from the name to the formula. So here we have names: potassium permanganate, barium nitrate, and lithium carbonate. Okay, we'll start off by identifying the formula of each ion and their applicable charges. So potassium as an ion is K, and because it's in group 1, that makes it a +1 charge. So the ion formula here is K+. Permanganate is MnO4 negative. Okay, so we've got K+ and MnO4 negative. Now we can do the crisscross method like we saw in class this week, where if we have the +1 and -1, then we are effectively taking the 1, bringing it down as a subscript for MnO4, and the other one down as a subscript for K. Essentially at this point, the 1s cancel out. So what we get for our formula is KMnO4. All right, in the next one, we have barium nitrate. Barium is Ba, and it's in group 2, so it has a +2 charge. Nitrate is NO3 with a -1 charge. Notice now we don't have equal charges, so we still have to do the crisscross. That 2 would come down here, and the 1 comes down here. What we get is barium with a 1 that we don't have to write because it's implied, and then we have NO3, 2. Now, this looks funky. It looks like we're saying it's NO32. That is not correct. Anytime where you end up having multiple polyatomic ions in a formula, so multiple meaning more than one, we need to put parentheses around that polyatomic ion to separate it from the subscript on the outside. So by having brought this 2 down to here, we're saying that we have 2 nitrate ions in our formula. As we saw with subscripts, anything that precedes the subscript belongs to it. So here we have 2 nitrates. And carbonate is CO3 -2. We don't have equal charges, so we have to do the crisscross. That 2 will come down here to lithium, and the 1 will come over to carbonate. So here we have Li2, oops, let's fix that, Li2CO3. And in this case, because there is only one of the CO3s, we need no parentheses. And we don't use parentheses here because it's a single element. So again, we use parentheses if more than one polyatomic ions are around. Okay, so we use parentheses if there's more than one polyatomic ion present. Let's look at one more example here, and then I'll let you get to it. Say we have the name ammonium. Let's go ammonium dichromate. Okay, ammonium is NH4 + 1, a polyatomic ion, and then dichromate is Cr2O7 with a -2 charge. So when we go to crisscross, we don't have equal charges, so we have to crisscross. The 1 comes over to be on the outside of chromate, or dichromate rather, and the 2 from the -2 charge comes down for ammonium. Now ammonium, because we're putting a 2 to indicate that there's 2 of them, we need to put ammonium in parentheses. And then dichromate, there's only 1 of them, so we can leave it alone and just have Cr2O7. That's it.